Hey kids, Flexing Teacher Weber here. I wanted to do one more video with another equation to show you how to graph linear equations when given the equation. So this is just like the first question we did, different equation though. It says y equals 2x plus 3, and we're going to make a table of values using positive and negative integers for x and 0, and we're going to make 5 ordered pairs. So just like we did in the first question, we'll make a table of values. We'll call the right side x and the left side y. Make this just a little more room there. There we go. And we're going to use our equation to get values for x. But first we have to decide on values for x. Well, it says use positive, negative, and 0 for x. So we'll keep it simple. We'll use our negative values. We'll use as negative 2, negative 1, 0, 1, and 2 for x. And now we have to use the equation y equals 2x plus 3, and we're going to use that equation to make the values for y. So we're going to use substitution. We're going to solve, replace the x with negative 2 first. So we'll do y equals 2 times negative 2 plus 3. 2 times negative 2 is negative 4, positive 3. And that's equal to negative 1. So when x is negative 2, y is negative 1. And we'll do this again. Y equals 2x plus 3. This time, we'll replace x with negative 1. So y equals 2 times negative 1 plus 3. Y equals negative 2 plus 3. And y equals positive 1. So when x is negative 1, y is positive 1. You can see that the pattern increased by 2 there. Let's see if that continues. We'll use the equation again, y equals 2x plus 3. We'll replace the x with 0 this time. Y equals 2 times 0 plus 3. Y equals 2 times 0 is 0 plus 3. Y equals 3. So when x is 0, y is 3. And that increase of 2 happened again. And so we can probably make a good hypothesis that when x is 1, y is 7. Pardon me, when x is 1, y is 5. And when x is 2, y is 7. And there we have 5 ordered pairs for our graph. Those aren't the only ordered pairs, though. These are just, there's unlimited, right? And that's what I want to show you in the next question. So the next question, we did one like this already. Determine the value for y in the ordered pair negative 12y by using substitution. So we'll take our same equation. This is the same question. Y equals 2x plus 3. But in this case, we're going to be substituting in negative 12 for x. So we'll do y equals 2 times negative 12 plus 3. 2 times negative 12 is negative 24 plus 3. And y is equal to negative 21. So when x is negative 12, y will be negative 21. Just want to show you that there's unlimited points for that line. Now we're going to graph the ordered pair. So let's make the ordered pair. It was negative 2, negative 1. It was negative 1, 1. It was 0, 3. And it was 1, 5. And it was 2, 7. We also had negative 12, negative 21, right? Okay, our x values are increasing by 1. So on our x-axis, the horizontal axis, where the x and y axis meet is 0. And then we can skip ahead 2 lines to make a large graph, and we can still just go up by 1 on the x-axis. Oh, I missed. Look at that. think I did this last time I made a graph too. 6, 7. And then negative values on the x-axis, -1, -2, -3, -4, -5, -6, -7. Now our y-axis, it goes -1, 1, 0, 3, 5, 7. I like that same scale we used last time. We'll go up by 2s. 2, 4, 6, 8, 10, 12, and 0, -2, -4, -6, -8. Okay, and my first ordered pair was -2, -1. So on the x-axis, I'll go across -2 down to -1 right there. Put my point right there. That's -2, -1. Okay, the next point was -1, 1. So I'm going to go across -1 and then up 1 on the y-axis right there. So there's my -1, 1. Now the next point was 0, 3, I believe. Yeah, 0, 3. So we stay on the x-axis and we go up to 3. And there's 0, 3. Then next, I believe, was 1 and 5. So we'll go across 1 and up 5 right there, and we'll label that 1, 5. And then the last one was x2, y7. We'll put that right there. That's 2, 7. And once again, you're going to see that this is called a linear relationship because the graph forms a straight line with those 5 points. And we join those 5 points. We put arrows on the end to indicate this graph could go on forever in either direction. And we write that this is the graph of y equals 2x plus 3. That's the equation that we're graphing. And this graph can go on forever in either direction. So those are 2 questions I've done now on graphing ordered pairs and creating a linear relation from an equation. I hope that helps. You have an assignment to work on where you have to do this sort of thing. That's all for now. Flexing Teacher Weber, out.